Okay, welcome to lab number 2 of Physics 2212. So this lab is kind of piggybacking off lab 1 and just updating the models to get a better measurement of the charge of the U-tape. So we're going to try dividing it into point charges. And at the end of the lab we got 5.9 times 10 to the negative 7 coulombs for the tape's charge. So for the background concepts, we have to know about charge, obviously, difference of point charge and, surface charge, summing it up to get that. We use Coulomb's law, Newton's second and third laws to calculate the gravitational force and then relate that to the electric force and use that algebra to solve for the charge. So one piece of tape was, again, 20 centimeters, same as last time. And the mass measurement was about 0.15 grams, which is 0.00015 kilograms. And they're about 0.04 meters apart from each other. So we calculate the force using Newton's second law, and we got 0.00147 newtons. Therefore, we know the electric force, since it's stationary, is the same amount of newtons upward. So the computational model used the square root of mass times acceleration times distance squared, which gave us 5.9 times 10 to the negative 7th coulombs. And we had to make a few assumptions. First of all, no air resistance, obviously, because who wants to deal with that, right? Am I right? And also we had to treat the long tape as though it was a point charge. So all the charge concentrated at the center. But treating the tape as a point charge, we did not have to do that because we were actually dividing it into a bunch of different charge. Same amount of charge throughout the tape, yes, we did have to assume that. Because if we have different charges at different points, we couldn't calculate one Q value. So what if we model each of the tapes as a single point charge like the last lab? Using the formula we used last time, then that gives us 1.62 times 10 to the negative 8th coulombs, which is 103% off from the value we calculated this time. So I guess we were way off. And these estimates differ because we're breaking up the tape into about 100 points instead of 1 point. So we're kind of approaching the value and with a lot better model than we used in lab 1. In conclusion, we learned that we can approximate a realistic model by treating a piece of tape as a bunch of point charges instead of one point charge. And with this lab, we're starting to see how we can make some real objects and model them in our world instead of just focusing on point charges. So I hope you enjoyed the video, and I'll see you guys next week. Peace.